Sorry I can't be here with you today. I'm doing some training myself. So this lesson's actually really quick, and it's all the stuff we talked about on Monday in 4.7, with just one more layer added to it. And so I think if you've practiced 4.7, I think that today's lesson won't be too difficult for you. Okay, so we're substituting. And we've done this in a couple other units, and it's a great way to check to make sure everything's working, and it's something that we do a lot in math is substitute. So you've got an expression here, so no equal sign, so it's an expression, and this is 4.7. Like, how do we get this smaller? What do we do with it? So there's two ways to approach this. You can actually go ahead and substitute in the values of -3 and +2, where you see these variables, right away. If working with numbers makes you happier, then you can do that. And I'm going to show you both ways. But what I like to do, because I'd like to get it simpler before I do the math, I hedge my bets. I think I'm better at the algebra and simplifying with letters and then substituting. That's my strong suit. So I'm going to simplify first, then I'm going to substitute. And then I'll show you the other way to do it. So let's go through and deal with order of operations first. So order of operations says I need to take care of what's in the brackets. And normally, that's exactly where I would start. I would simplify using my exponent rules, and we'll go from there. But what I would like to do first is I'd like to deal with that negative exponent. So if we remember back from, so I'm going to put a number 1 by that, because that's what I'm going to do first. I'm going to deal with that negative. So if you remember back to Friday, we did negative exponents. And so that negative means we're going to reciprocate the base number. So reciprocate's just the mathy way of we are flipping it upside down. So I'm going to deal with that. So that's going to be a to the exponent 5, b to the exponent 8. They were downstairs. Now they moved upstairs. And the upstairs people moved downstairs. Now that's still, so I used my negative exponent, so that's gone. And now that's squared. So I like dealing with that negative, getting it out of the way first, because it makes things a little bit easier for me. All right, so now I'm going to use my exponent rules to simplify what's inside the bracket. So I'm going to look at the a's. So they have the same base of a, and then we go ahead and we subtract the exponents. So we're going to have a, and numerator always comes first, so 5 minus 6, and then we're going to have b, 8 minus 9. And that's still going to be squared, because I haven't done anything with that yet. So I'm going to have a to the -1, and b to the -1, and all of that is squared. I've run out of room already. I don't know why I didn't expand this for us. So I'm just going to move up here. So now I'm going to use my power rule, and I'm taking the exponent inside, and I'm multiplying it by the exponents inside the bracket. So I'm going to have a to the exponent -2 and b to the exponent -2. Now again, I've dealt with that, so it's no longer there. I've kind of leapfrogged it in. I've multiplied it to here, and I've multiplied it to there. -1 times 2 is -2. So there we are with the solution. So we've simplified it. That's 4.7. So now what I'm going to do is I am going to take my values, and I'm going to substitute them into the more simplified view. This is what works for me. Like I said, there's two ways of doing it. And whatever works for you is either way is going to be okie dokie with me. So -3, because it's a -3, I'm going to use brackets. And that's going to be to the exponent 2. And you know what? Just for funsies, I'm going to use brackets on the 2. And that's to the -2. So now we have to evaluate these things. So we know that this negative is going to reciprocate the base. So that negative there is going to reciprocate the base of -3. So that's going to become -1/3. And now that's going to be a +2. And this is going to reciprocate to 1/2. And notice those negatives go away because I've dealt with them. So now I'm going to go ahead and I'm going to apply my squareds. So that's 1/9 because a negative 3 times by a negative 3 is a positive 9, and this is going to be 1/4. And when we multiply fractions, it's straight across the top, straight across the bottom, so it's going to be 1/36. So now you've gone ahead, you've simplified, and you have substituted. So this part of the substituting, this part here that we just did, that's the 4.8 part, okay? But you can't do this question without knowing 4.7. So I'm going to show you the second way, and I'm going to do it on a piece of paper just because I am running out of room. So I have a to the exponent 6, b to the exponent 9, over a to the exponent 5, b to the exponent 8, all to the exponent negative 2. Okay, and we said that a has a value of negative 3, and b has a value of positive 2. Okay, so knowing this, what I'm going to do, the other way you can do it is you can substitute the numerical values in right now. So we're going to have negative 3 to the exponent 6, 2 to the exponent 9, over negative 3 to the exponent 5, 2 to the exponent 8, all to the negative 2. Oh, that green pen isn't very good. Let me grab a different one. Okay, so I gotta get a calculator. And now all of a sudden the numbers are getting really big, and I don't like it. But I'll be okay. Yeah, I'll be okay, I promise. So in my calculator, I'm putting negative 3 to the exponent 6. Holy Hannah, that's a big number, 729. And then 2 to the exponent 9 is 512. All over negative 3. Oops, forgot my brackets on that, so that would have been a wrong answer. Negative 3 to the exponent 5 is negative 243, and 2 to the exponent 8 is 256. And that's all still to the exponent negative, you guys can't even see that. So it's all still to the negative 2 because I haven't done anything with it. All right, here we go, big number, 729 times by 512. 373,248 over negative 62,208 to the negative 2. Okay, so the reason why I don't like doing it this way is because I'm gonna have to simplify this fraction, and that kind of makes me want to cry a little. But we're still not done because we got to deal with this exponent on the outside. So the negative tells me I'm going to reciprocate the base, so it's going to switch to negative 62,208 over 373,248, and now that's squared. So I'm going to go ahead and I'm going to simplify what's inside first. So I'm going to simplify, I'm going to grab a yellow highlighter because my pink one never works. I'm going to simplify that because if I try to square that, my numbers are just going to get bigger and I'm going to cry a little bit. I know what the answer is. So what I'm going to do is I'm going to take the 373,248. I'm going to see if it's divisible by my negative 62,208. So what I have 373,248, and I'm going to divide it by 62. Ooh, I forgot my negative sign. I'll know the answer is negative. And okay, it works. This is a nice one, and I knew this because I had simplified first. So yeah, the other one was a few more steps, but I find simplifying letters way easier, like doing my exponent rules way easier than numbers. So again, this is my love of no calculator. So this is going to reduce to, so if this goes into this 6 times, this is going to be reduced to negative 1 over 6, and that's squared. And so I will have a positive 136, which is the exact same answer I got from doing it the other way. So nothing should be a shock, and I already knew what kind of answer I was working towards, so that made it a little bit easier. So I am okay if you want to simplify first, then substitute, or if you want to substitute first and then simplify. I'm okay whether you do it either way. I can follow the math no matter what. So it's really up to you. Okay, we got 4 examples to do real quick, and then you're good to go. You'll have the rest of the period to work on the assignment. So I'm going back to my booklet. And if you need to pause the video because I'm going too fast, which is very possible, do so. Pause it. Make sure you get a copy down. All right, so here we are with A. And we're going to go back and we're going to do the substitution. Now, please remember that this is going to be on your quiz. So we're going to stick with what we got upstairs. All right, we're going to stick with those two. That 136 belongs with that question up there. Okay, so I'm looking at this one. The only thing I can do here is the power rule. And one thing that students make the mistake of time and time again is they forget that 8 has a invisible exponent of 1. Lots of students forget that. No matter what grade they're in, they're just rushing through and they're not thinking about it. So just keep that in mind. I know you're not every student. I'm gonna try to change to a purple. We'll see if that works. So we're gonna use the power of the power rule. So we're gonna multiply the outside exponent to every inside exponent. So we're gonna have 8 to the 1/3. We're gonna have A to the 3/3, and we're gonna have B to the 6/3. Okay, and that does not look like a purple pen, but we'll go with it. Just a quick note, I'm gonna just, again, go to my scrap piece of paper here, slide this over. So we had 8 to the exponent 1, A to the exponent 3, B to the exponent 6 to the 1/3. So it's like saying 1/1, 3/1, 6/1, right? And when we multiply fractions, we multiply straight across the top and straight across the bottom. So when we're looking at this one, this would be 3/1 times by 1/3, which would result in 3/3. Okay? Oh, that's supposed to be a 3, but I don't even know what that looks like. So just so you know how I did that really quick, that's what I was doing there. And then this one would be 6/1 times 1/3. So that's going to be straight across the top and straight across the bottom. So 6/3. Okay, pretty straightforward for that one. So we're going to simplify the fractions if we can. So we're going to have 8, 1/3, A to the exponent 1, and B to the exponent 2. Okay, pretty exciting stuff. So if we think way back to, where was that? Rational exponents, 4.5. This tells me that the 8 has an exponent of 1 and a root of 3. So this is going to be the cube root of 8 to the exponent 1. And we're going to substitute our values in now. So I'm going to take my -3. I'm going to replace A with -3. That's to the exponent 1. I have 2 to the exponent 2. So we know that the cube root of 8, hopefully you all know that that's 2 by now. We know that's -3. And we know that that's 4. And we're just going to go ahead and multiply them. So 2 times -3 is -6. -6 times 4 is a -24. I should probably leave more room. I don't know why I put it in brackets. Just bad habits, good habits, I'm not sure. Okay, I showed you all the steps, and if you want to go from here to here, that's fine. Like if you want to go from this right to here, and if you want to go from there right to there, I'm okay with that too. Like, so you can shorten this. We're mathematicians, we want to be efficient. So I'm just going to slide this over here. We're going to apply our exponent rules. There's no exponents on the inside now. We're just multiplying them, so that means we're going to add the exponents. So we're going to keep the base of x, and we're going to add 3/2 plus 1/2. Ooh, they have common denominators already. Life is good. And then that's multiplied by, and maybe if we put some big brackets around it, that might make it look a little nicer, 2 plus a -1. Okay, So great thing. These nice and easy. I don't have to get common denominators here. So when you're adding fractions, you add the numerators and you keep the denominator. And then we're going to multiply that by y to the exponent, y to the exponent 1. Simplify that, so that's going to be x squared times y to the exponent 1. Now I'm going to go ahead and substitute. So again, I really do like to simplify first, and that's going to be the way I show you, because I think dealing with letters should become more comfortable for you guys as we go on. So we're going to have, just going to continue that on up here. So we're going to have, I don't know what x and y are. I only know a and b's. Okay, so that's it. We're done, because we only have information for what a and b are. We don't have x and y. So maybe we'll just leave that one as simplified. Now you might not have the brackets in it. You might have this, which this one and this one are equivalent, which is great. Life's good. Don't know why I switched to x and y here, folks, but you'll be okay, I promise. Okay. All right, let's do some math. So I'm going to look at those coefficients first. And that says if we just look at those in isolation, 4 divided by 2, and I think we all know that. That's going to be 2. But it's really a 2 over 1. So keep in mind that it's 2 over 1, or if you're reducing fractions, which we'll talk a little bit more over here. Oh, we won't talk about it over here, but it's okay. So now with the subtracting, because we're dividing, we keep the a, and we have negative 2 minus 2. We'll put that in brackets. And then we've got b to the 2/3. Remember, you're always taking the exponent on top and subtracting the one on bottom. And again, this is from Monday, so hopefully you've had a chance to practice this and you don't feel like it's too terrible. All right, there we go. That's pretty exciting. So now we're going to do our substitution part of it. So we've got 2, negative 3. I'm going to put that negative 4 outside just because the negative 3 is my base and the negative 4 is applied to the whole thing. And then I have 2 to the 1/3. Yuck, that's not going to be fun, but it'll kind of be fun. Okay, I think it'll be fun. You guys are just going to have to bear along with me. Okay, so we've got 2 to the exponent negative 1/3, because that tells me to flip it, and that's all to the exponent 4. And we know that this means that 2 has an exponent of 1, but a root of 3. It's going to be the cube root of 2 to the exponent 1. All right, 3 to the exponent 4 is 81. So we're going to have 2, and it's an even root, so this is going to change to positive. So it's going to be 81 cube root 2. Okay, that kind of looks messy. And we talked about this, remember this was 2 over 1. So if we multiply these fractions straight across the top, straight across the bottom, so I'm just going to move over here, and we're going to get 2 over 81 times by the cube root of 2. So I have a coefficient of 2 over 81, and I have the cube root of 2. And I think I'm going to stop here. It's very, they're not, I won't say they're ugly numbers. They're just, this doesn't divide evenly, so it doesn't give me a nice whole number. And I can't take the cube root of 2. That's going to be an irrational number. So I'm going to leave it like this. This is as simplified as I'm going to get. Decimals aren't always the simplified. This is fully simplified right here. So a coefficient of 2 over 81, so that means we're multiplying that by the cube root of 2. I know, super exciting. Just give you a second to write that down. Whew, I am running out of room. I don't know about you guys. I probably should, I'm going to make a note to space this next year over 2 things. 2 thingies. 2 pages is what I'm trying to say. Okay, now moving on to this one. Again, I'm going to look at those coefficients just by themselves. So 100 divided by 25, so that's going to leave me with 4. We're going to have a to the exponent 1 minus 5. And there's no b on top. That's interesting. Remember what anything to the exponent 0 is? It has a value of 1. So we can actually put a b to the exponent 0 there, which is kind of cool. So b, so I've got 0 minus a negative 1/2. And that is all to the exponent 1/2. Whew, this isn't friendly. This is not friendly numbers. But that's okay. That's okay. We're smart people. We can do this. We're going to remember that there is an invisible exponent of 1 on the 4. That helps better for the leapfrogging. So the power rule says I got to multiply it by the exponents in the bracket. So I'm going to do that. So I'm going to have 4 to the exponent 1/2, a to the exponent negative 4 over 2, and b to the exponent 1/4. All right, a little bit ugly, not too terrible. This can be simplified, but none of the other ones can. But what this tells me is I've got a square root of 4 to the exponent of 1, and b has a 4th root, and b's to the exponent 1. So I've got the square root of 4, I've got a to the negative 2, and I have the 4th root of b. I'm going to put brackets around these just to remind myself that I need to multiply them. And now we're going to substitute in our values. We can actually evaluate the square root of 4. There's no variable attached to it, so we can do that really quick. That's going to be a 2. A is negative 3 to the exponent negative 2. And then we're going to take the 4th root of 2. Now, some of you, keen beans, know right away that that negative is going to flip this to a negative 1/3. You guys are brilliant. Because you're getting good with negative exponents. This is going to be... Does it matter that my negative moved on top? Doesn't. The fraction itself is negative, so it's not that big of a deal. And I'm going to have the 4th root of 2. And again, that's an index, not a coefficient. So I'm going to have 2 times 1/9 to the 4th root of 2. And we know that the 4th root of 2 is going to be an irrational number. So we're going to have 2/9 to the 4th root of 2. And that's going to be my final answer. So at no point did I have to reach for my calculator. These are really nice numbers that we can work with. And leaving it in fraction and radical form makes things a lot simpler. I will tell you that on your quiz on Friday, you are going to be asked to leave things as positive exponents and leave your answers as fractions or integers. So no decimals. So you've got to know the steps to do it. You can't just rely on your calculator to do it. All right, team. I apologize again for not being here. But I know you guys are going to do great. This is just one extra step, and we will see you tomorrow. Have a good day.